So please look at this particular diagram, which shows phases or stages of machine design. So whenever you want to launch new product, whenever you want to design any new product comprises of many components, many machine elements. So new product can be designed by this particular way. So this is the channel. Okay, so market survey, product specifications, study alternatives, select suitable alternatives, select joining method, design individual element. Correct. Design individual element, prepare assembly detailed drawing, testing, and go on modifying product whenever needed. Now we will be focusing on this particular step, and that is design of individual machine element. So we have to design individual machine element, individual component, and by designing those individual components we will be preparing assembly, and then we'll be testing the assembly. So you take case of any product, that product has number of machine elements. So different components, different assemblies, I will be giving you example of which you have learned in mechanical working drawing. So you have learned bearing, two kind of bearing, ball bearing. So where components are balls, cages, inner race, outer race. We have learned plumber block or pedestal bearing. In pedestal bearing also there are several components like sleeve is there, cap is there, body, different screws are there, nut there, lock nut is there. So these are individual components, and whenever we will be designing individual components, then it is possible for us to design a particular component. Now we will be starting with the design of individual machine element. So what is the first step in designing machine element? The first step in designing machine element is to specify and to understand function of machine element. So when anybody tells me that you are supposed to design any machine element, what I will be considering? First of all, as a design engineer, I will be considering its function, its purpose. Suppose I want to design my own washing machine. So many a times in project we choose this particular project to have a cycle operated washing machine. There I am supposed to design shaft. So whenever we say shaft, in many situations we have seen shaft. So there is axle in case of two-wheeler, in case of four-wheeler also there is stub axle, there is shaft of motor, shaft of pump set. Is it? All are identical, all are identical, round one, maybe hollow or solid, but function of every shaft is different. Function of every shaft is different because forces acting and what kind of forces that particular machine element is supposed to bear is different. So when it is supposed to design shaft of washing machine, I have to consider that what is function of washing machine first, and then I will be understanding that what is function of that particular shaft. Means shaft is supposed to support the drum, and the forces acting on drum is the weight of that weighted clothing, and due to that some force will be acting on that machine element, number one. And there is swirling action, swirling. So due to that centrifugal force will be generated. Are you understanding the fact? So as swirling action, drum is rotated, centrifugal force is acting over the clothings, and due to that some load is acting on that particular shaft. So what becomes function of the shaft? Shaft is supposed to hold the drum. It is supposed to hold the drum. It is rotating drum along with clothings. Is it? Number two. And shaft is supposed to operate at different speeds. different speeds. So at a different speed, that shaft will be run. So whenever I am supposed to design any machine element, I will be understanding its function. Suppose I want to design some lever. You have learned lever operated safety valve in case of boiler. What is duty of lever operated safety valve? Why that lever operated safety valve is provided? You type lever operated safety valve. It is safety valve, is it? So once a particular pressure reaches, that valve will blow and steam will escape from boiler. So what is the function of that lever of safety valve? Lever of safety valve is maintaining some load, some pressure, creating some pressure over the hole provided inside the boiler. Is it? So if that valve opens, steam will come out, and steam should not come out up to a particular pressure. Suppose that valve is designed to blow off at 175 bar pressure. Till 175 bar pressure reaches, it should close that particular opening. Is it? Once pressure reaches 175 bar, it will blow off and steam will escape and pressure inside boiler will be maintained. So the lever of that lever loaded safety valve is important, because if lever is not used for that 175 bar pressure, I need to have very huge dead weights. If lever is not used, very heavy dead weights are required. So as I am using leverage, is it, what will be the force? Please understand well. It is the force acting, that is weight acting at the end multiplied by length of that particular lever. Is it? Length multiplied by weight which is hanging at the end. So you know that in case of lever loaded safety valve, some weight is hanging at the end. So length of lever from valve center to that particular weight multiplied by the weight will be creating force so as to shut off that particular valve up to 175 bar pressure. So this becomes function that lever is supposed to maintain valve closed up to 175 bar pressure, and lever should be designed in such a way that valve will open at 175 bar pressure. See, there is again a mix of length of lever, because it is product of length of lever multiplied by weight of that particular lever. Naturally, we have to consider proper length of lever. So this is the first step in designing machine element, and that particular step is to specify function of machine element. We have to specify machine element. In a diagram shown on left, I have shown a shaft. So are you understanding? A figure which is very much descriptive is shown over here. In strength of material, you have learned that some beam is there. So here I have shown some beam. Actually, it is shaft. Shaft is supported at two different ends. RL and RR are the reactions which are acting, created at the shaft due to load. Actually, reactions are reaction to the applied load. I will be telling you in detail. So RL and RR are the reactions due to whatever load coming on that particular shaft. And are you understanding? MT I have written. MT is what? MT is the twisting moment. And that twisting moment is 50 kilonewton meter. So shaft is rotating. As shaft is rotating, the torque on that particular shaft is 50 kilonewton meter. Torque is 50 kilonewton meter. Consider that shaft is transmitting 50 kilonewton meter torque. Torque, is it? Torque depends upon power which it is transmitting. You know relation in between power and torque. P is equal to 2 pi nt divided by 60. Few more forces are shown by red arrows. One is downward arrow, said as FR. FR, it is radial force, is it? So it is FR. It is acting downward. Why it is radial? Acting along radius of that round member. So this is round member and acting along radius. So it is FR, 40 kilonewton. And another is abbreviated as FA, which is 5 kilonewton. So 5 kilonewton force is acting on that. So I have shown this as an example which we will be learning. So the first step is to specify function of this machine element. I will be understanding function of this machine element, that it is a shaft which is transmitting power, and as it is transmitting power, I will be relating at what RPM that particular shaft is rotating, and the next step is determining the forces acting on that particular machine element. So I have described in this particular figure. So once I know function of a machine element, next step is to determine forces acting on that particular machine element. So understand well that I have told you earlier that there should be aesthetic aspects, there should be ergonomic aspect, but what is foremost important? Foremost important is to have strength. Strength. Every machine element should have strength. And in case of design, I will be showing you simply that what is strength. So it is performing its function, that is strength. And in physics, we may say that strength is what? It is reaction to the applied forces, able to resist applied forces. A chair is strong, but does it remain strong when 2 or 3 people simultaneously standing on the chair? We, whenever purchasing chair, we ensure no, we sit on chair, okay, we move on chair and find that whether really joints are tight, whether it is able to sustain my load. Am I correct? So whenever selecting chair, we verify that chair is strong, chair has strength. But when you will be testing it by standing 2 or 3 people together on chair and it fails, will you say chair has no strength? No, because chair is designed to sit and not for 2 or 3 people simultaneously. Are you understanding that particular fact? So same is the case for two-wheeler. In case of two-wheeler, we should carry some load. If you carry more load than the rated load, more people than 2, huge weight, some 2-ton load you are carrying on vehicle, naturally it will be having damaging effect on that particular vehicle. So whenever we say that any product is strong or it is having strength, means it is able to resist the applied forces. And whenever any product is designed, it is designed for certain force. Understand that whenever any machine element is designed, that machine element is designed for some force. If we apply more force than that, naturally it will fail. Okay, so we have to determine the forces acting on that particular machine element. Because we are designing machine element, means we are making resistive design to applied force. Our design is strength oriented. Design is, or it should be strength oriented. It should have adequate strength. Whatever we are designing should have adequate strength. That is foremost important. And how we may claim strength? It is by determining the forces acting on the particular machine element. For a design engineer, this is very important step. For design engineer, determining forces on machine element is very important step. If we fail to understand forces, so in this particular case, say there are how many forces acting in the diagram? Please comment in chat box. Are you attentive? Please type in chat that which are the forces acting. Okay, Sarthak, 3 forces acting. Okay, what are other comments? How many forces are acting on this machine element shaft? Do you agree with Sarthak? Single person is replying. Okay, Lard saying 2 forces are acting. See, I want 108 comments. You are 108. I want 108 comments. Desai Kharat says 2 forces. Okay. Okay. Right, 2. There are 3 forces acting. I go with Sarthak. There are 3 forces acting. So 2 forces are directly seen in this diagram. One is the radial force, 40 kilonewton. Is it? Another is axial force, 5 kilonewton. And third one is the tangential force. Third one is tangential. Is it seen? Whether tangential force is seen in the diagram? No, it is not seen. It is the force due to torque. Is it? As the shaft is transmitting some torque, that 50 kilonewton per meter, it creates tangential force on a shaft. This is the third force which is acting on this shaft. So I may say that this shaft is subjected to radial force, axial force, and tangential force due to torque transmitted by this particular shaft. So we should not fail in determining the forces acting on element. So all kind of forces, maybe small or maybe large one, we should be in position to estimate, determine the forces acting on that particular element. We have to think that shaft is rotating and it is transmitting power. You know how power is transmitted? By means of belt, maybe by using chain drive, by means of gears, gear train, whatever kind of power transmission. As shaft is transmitting power, depending upon how much power it transmits, torque we will be finding, and we will be finding that what will be the tangential force acting on that particular shaft. If you fail to analyze this particular force, what will happen? The shaft you have designed only for radial and axial force will fail when it is rotating. Are you understanding the fact? If I estimate just radial and axial force, and don't estimate that torque. What will happen when shaft rotates? After some time, we will find that it fails. May it will break into pieces, or bearing will fail, and jamming action will get created, whatever may be the mode of failure. But analyzing the forces, determining the forces acting on machine element is very important task. I am happy because you have not said four forces. You have either said two or three forces, because reaction are those forces, those are the reactions. This understanding is clear to you. Okay, so you are wise enough. You have either told two or three forces. I was expecting that somebody should say four forces. So nobody has told that. So concepts are clear to you. This is indication that concepts are clear to you, because RL and RR are the reactions due to these three forces which are acting on that particular shaft. These are the reactions. So whenever you are going to design any machine element, you have to determine what forces will be coming on that particular machine element, and very clear understanding, estimating is necessary in case of forces. See, when we are saying determining the forces, number one, we have to locate the force. We have to understand that where that force is acting. So FR and FA are the forces acting radially and axially. So we should be in position to tell type of the force, direction of the force, I mean. So depending upon direction, I will be saying force has radial or axial, or it is having tangential. So depending upon direction, we are in position to classify forces in terms of axial force, radial force, tangential force. Is it? Force is a force, but how it is acting on machine element, what effect it is causing, depending upon that, or line of action of force is telling us that whether it is radial, axial. See, force is axial because it is acting along the axis of that particular shaft. Tangential because its line of action, its direction is tangential to the shaft. In this diagram, it is not seen, it is tangential, but in side view, I could have shown that particular tangential force. You imagine that. So how tangential force works. In case of turbine, you have learned that how tangential force acts. In case of Pelton wheel, jet, tangential jets we call, no? Jets are tangential to the blades. If jets are not tangential to the blades, then the rotor will not rotate. Is it? So determining forces means I have to find number of forces, how many forces are there, where forces are acting, location of the forces, type of force, is it radial, axial, tangential, radially outward, radially inward. So we should classify that particular force, and we should be in position to quantify, find magnitude of that particular force. Here I have written directly magnitudes, 40 kilonewton, 5 kilonewton. So based on the analysis, we will be finding out that how much radial force is coming, how much axial force will be coming on that particular shaft, what will be the twisting moment. Twisting moment I will find from power. Axial force is if it is a shaft of vehicle, say axle. So whenever cornering, that axial force will be coming on that particular axle. So determining the forces means we should be in position to identify number of forces. We should be in position to find direction of the forces, location of the forces, where force is acting. Is it at the center? Is it at the end? Or at a particular distance from any end? So we should be in position to analyze location, and we should be in position to tell correct magnitude of the force. See, if anything fails, if you consider wrong magnitude, your design may fail. If you consider wrong direction, instead of radial force, if you consider 40 kilonewton as axial force, then the stresses working will be different, and in practice that design will fail. So this step is again important to determine the forces acting on machine element, which is the second step. Now let us move ahead, and this step again is important because the ability of any material to sustain the force, I repeat, ability of sustaining the force depends upon material. Every material will not be having same strength. Every material will not be having same strength. Strength depends upon material. So you will not find that copper has same strength that of steel, that of mild steel, that of cast steel. Is it correct? So by melting also you can shape copper. Some more force efforts will be exerted on steel, but just by melting you are unable to give shape to the mild steel. We say it is hard. We say strength of mild steel is more. That means selecting suitable material is a very important step in designing machine element. And every material do not have same strength because properties of material are different, strength of every material is different, and we know that in actual practice many alloying by heat treatment, it is possible to improve the strength. There are inherent properties of every material, and those inherent properties of material can be enhanced by heat treatment, different surface treatment, and by that strength of material can be enhanced. So we have to select suitable material. How to select suitable material? Selecting suitable material depends upon how much force acting on that machine element, magnitude of force. It depends upon direction of the force, direction in which forces are acting on that particular machine element. Selection of material is driven by cost of material. See, some materials are having good properties, but those materials are not cheaper, not economic. Gold we may not use, is it? Aluminium we may not use ordinarily. So whenever weight is a concern, then aluminium is used. So selection of material is necessary, and selection of material is done in accordance with what forces are acting on the machine element. So that different metal, non-metals, metalloids are available. Again, there are ferrous, non-ferrous metals, is it? And for every maybe ferrous, maybe non-ferrous material, we'll be having classification of material. That ferrous material may be steel, cast steel, it may be stainless steel, it may be plain carbon steel. We have learned that, no? We have learned material, is it? So ferrous, maybe steel, maybe stainless steel, we may use cast steel, we may use plain carbon steel, which is again classified into low carbon, medium carbon, and high carbon steel. Which material will you choose? Is it arbitrary? No. The choice depends upon how much any material elongates, what will be the strength of material. That means how much force any material can withstand, how much force any material will resist. Take into consideration that I will be designing shaft made up of stainless steel. If I design shaft made up of stainless steel, what happens is shaft is rotating, and whenever some braking action is applied, shaft get twisted. So consider that shaft is rotating and its rotation is suddenly stopped. Twisting action takes place. Twisting, you understand? Twisting action will take place. So it will be having elongation. So more elongation is possible. So we may not choose stainless steel if elongation is a criteria. So in that case, I will be going for mild steel, but again mild steel has elongation. So where I want less elongation, I will choose plain carbon steel. Is it? So selection of suitable material is necessary. So this is the third step, is to select material. And please understand well that strength of material is different. Strength of material is different. And ahead in the practice of this machine design, we will be learning that there used to be yield strength and ultimate strength. So we will be deciding that up to what particular stress we may load component made up of mild steel, component made up of plain carbon steel, say low carbon steel, medium carbon steel. So every material has different strength, and we will be choosing material based upon what I require and what is there in a material. In simple words, I will be saying that we are going to match our requirements with properties in material. I don't require elongation. I want that whatever material I will be selecting should withstand shock load, vibration. If it is Pelton wheel, if it is axle of a vehicle, shock loads are there. Shock load, you understand. Vibration is there. So vibration should be taken up. Shock load should be taken up. So I will be choosing such a material which is going to resist this load due to shock, vibration, and it will be again having adequate strength. Many a times additional properties like wear resistance, corrosion resistance are important when you will be selecting a shaft for chemical plant. Suppose shaft of washing machine itself. Shaft of washing machine is exposed continuously to the corrosion. Is it that washing soda shaft of washing machine drum is exposed to that detergent, and by means of which the erosion is possible, means life of that shaft will get affected. And for that sake, you know that drums are designed out of stainless steel. Drums are designed out of stainless steel, which has high corrosion resistance. So selection of material depends upon working condition, depends upon what we want in a particular machine element and what is there actually in a material. So we are matching our requirements. I want corrosion resistance, I want high strength, I want shock resistance, I want to sustain vibration. So I have to choose such a material which is able to sustain vibration, which is able to sustain shock load. So you know that machine beds are having cast iron. Cast iron, we know cast iron is brittle as compared to the plain carbon steel. Brittle, breaks easily. So by hammering also it will break. But it is shock resisting, it is going to absorb vibration. So the beds of machine are designed by using the cast iron. So selection of material is again a important task in case of design of machine element. Now the fourth step. What is the fourth step? It is determining modes of failure. So this is what we will be learning in design. Okay. So determining forces, selecting material are the previous step, and the next step is to determine modes of failure. Mode, how failure will occur, how any machine element will fail. That is called as mode of failure. I have listed some mode of failure here. This is not exhaustive list. I have listed some, given some example of a mode of failure like bending. Any machine element will fail due to bending. Is it? If you consider bar and on those bars, many people are pulling the bar downward. What happens? Bar will bend. Is it? It will bend and it will none of our use. So we say that it fails due to bending. You have work on lead machine. Consider that spindle of lathe machine will be bent. What happens is chuck will not rotate true. There will be revolving action, not rotational. Means chuck will not rotate its own axis. It will rotate around any other axis. So bending, due to bending, bearings will get affected. Okay, bearings are always used. So nevertheless, you will find that the shaft gets bent, but due to bending of shaft, bearings will fail. And failure of bearing can be known by noise of the bearing. In case of ceiling fan, so you know that ceiling fan, after some time, few years, you hear noise from those bearings. Why noise? It is due to the revolving action of that particular shaft. Shaft is vertical. In case of ceiling fan, it is vertical shaft supported by the bearing. And when continuously that fan is rotated, if it is not correctly fitted with the ceiling, it wobbles. And due to that wobbling action, bearings will fail and that noise can be heard. So we say that we have to change the fan, means fan has failed due to bending. Another is twisting, twist, twisting action. So it is possible that the component will get twisted and by that failure occurs. One more reason I have written that compressive stress. So there are many modes of failure. Due to excessive tension, it will fail. Tension. Suppose you are pulling some rope, and what happens with rope is that rope breaks. fails. Is it? So mode of failure, when you are pulling the rope, rope is subjected to tensile stress, and due to that, rope will get cut. Rope will get cut wherever it is weak, and we say it is failure of that particular rope. There are different modes of failure, and for design engineer, it is very important to understand modes of failure, how any machine element will fail. A design engineer means we who will be learning this machine design should be in position to understand that how any machine element will fail, that we call as mode of failure. So in case of any machine element, we should be able to find modes of failure. Suppose shaft, as it is subjected to radial force, bending will occur. Axial force is there. That axial force is causing compressive stress. And as that shaft is transmitting power, twisting action is possible. Twisting action is possible. Is it? So modes of failure I have written particularly in above example. So this is not exhaustive list. There are many modes of failure which are possible. So the fourth step is to determine modes of failure in case of any machine element. Next one is to decide shape and size. Okay, we will be discussing next steps in tomorrow's lecture, right? For today's sake, I will end this demonstration. You will be having power engineering and refrigeration lecture now. You will be having PER, power engineering and refrigeration lecture now. Okay, so is it clearly understood to all? We have learned 4 steps in design of machine element, which starts from specifying function of machine element. Next step is to determine forces acting on machine element. Third step, we have to choose suitable material. We will be determining modes of failure.